So good afternoon, everybody. Welcome back here in the room, and also welcome back to the people that are, following us online. So I think we can kickstart the last session of this 2 days marathon of Earth observation, in which we've been deep diving into several aspects that concerns this very specific field. So it's the turn right now of E-shape, which we will know a little bit more about it in just a second. I would like to remind to all the people that are following us online to use the Slido in order to pose questions to our panelists here. And here you go. Now you can see also like the QR code. So don't forget to connect to Slido to just interact with us, also to the people here in the room. And I think that with no further delay, I can start the session here. So I also prepared a little bit of an introduction in order to set the stage and to provide a couple of information on the project itself. So we've been talking a lot during the last 2 days about challenges and opportunities for the users' communities to integrate Earth observation data in their own workflows. And here I just wanted to provide a little bit of a recap of what could mean for the different users to integrate those data. So in terms of challenges, we realize that there's most definitely a lack of knowledge from the user side on the possibilities that are offered by Earth observation. And the opportunity, of course, is for us, for the community here, to find new ways and more effective ways to communicate about the benefits that they can bring to the different communities. On another challenge that we realize is a little bit of a lack of technical skills from the user side, but this again can be most definitely overcome by the additional training, info sessions, and most definitely success stories, and let's say brought by the users themselves. Again, another challenge that we've been talking about is the importance to be able to address user-specific needs. User-specific needs that might change from the different communities and that can be addressed by the solution that are currently provided. But yet again, this is also an opportunity for the sector, which can most definitely develop new technologies and also like leverage, let's say, the free and open data possibilities offered by the Copernicus and Galileo programs that we have. On the other hand, again, as a challenge, we realize that there is a certain difficulty in the procurement purchase of those solutions, mostly deriving also from this lack of knowledge of what is already available in the market. And yet again, we know that there is an increase in the offer and a growth of the market that should be most definitely, let's say, leveraged in this sense. When it comes, again, to the sustainabilities of the service, we have discussed during the last days about the need for established relationship between the different actors that are active, let's say, in the sector itself, in order to make sure that all the possibilities are grasped. This is very much connected with E-shape, and I think that, yes, with E-shape, because E-shape, as I will mention in a couple of seconds, is based on the interaction of the service providers with the users. So E-shape is a 48 months flagship European project, which is basically building the European contribution to the Geosystem of Systems initiative, and is a 15 million euros project, let's say comprising 67 partners, for a total of 37 pilot projects which have been developed within 7 thematic areas. So the 37 pilots are building on the capabilities of the European Union in terms of Earth observation and cloud computing, and are basically bringing those services to the next level of operability. The main pillars around which the E-Shape project is built are three, and are the co-design, maybe just for the people who are online, if I can change. Yes, please. Thank you very much. It's co-design, implementation, and user uptake. Co-design, which is basically at the basis of what I was mentioning, and is the development of services with and for the users. So the users have been engaged, and they have been co-designing those services, really addressing their specific needs. And implementation, which is what basically I mentioned earlier, and it's the fact that those services are not duplicating efforts, but it's really like building on the capabilities that are already out there and the different European assets when it comes to cloud computing and Earth observation and user uptake. So what we are going to do also today with this workshop, it's to make sure that the services are not developed for the sake of let's say, development of the technology, but that are really like integrated into the workflow of the different users. And this is why today with us, we have also representative of different users communities that will tell us a little bit more about their own perspective and the needs that they have at the moment. So I think that by saying that today we will focus a little bit better on three of the thematic areas that I showcased earlier, which are climate, energy, and water resources. I will immediately give the floor to my speakers here, and I will start by introducing the first speaker in line, who is Dries from Solar Europe. And he's the policy director and is responsible for the policy work of the whole association. And today will present us the European approach to the RES zoning. So, Dries, the floor is yours.
Thank you so much, and thanks for inviting me. It's a real pleasure to be here to discuss this important topic. I have 2 slides, which is not too much, but maybe before we look at the slides, maybe just to give you a bit of a step back perspective. These are special times to be in from an energy point of view and from many other point of view. Simply because what we're seeing is that we see an acceleration of the energy transition. The energy transition has been going on for quite a while. We are integrating more and more solar and wind into the energy system, EVs, some other things happening that are gradually replacing fossil fuels. But compared to what is still going to happen, it's been kind of peanuts so far. And it is an important thing to understand that the actual scale of the energy transition and of the deployments of solar and wind is far from the scale and the speed that we actually need. And I would also say that we're actually going to start seeing. The climate agenda has, of course, been quite important in driving the energy transition so far, but something new has happened. And it's, of course, also very tragic, but what we're seeing is that the Russian aggression in Ukraine has really changed the debate on energy in Europe. European leaders have set themselves a goal to disentangle the European economy from Russian fossil fuels in the next 5 years. And that is if we are allowed at that time, because maybe a Russian leader decides that for us. But so basically what's going to happen is that in the next 5 years, something heroic is going to happen. We're going to reduce the fossil fuels and have to replace it by something else. The whole idea is that we don't just replace it by other fossil fuels that are not from Russia, but from other parts of the world. That would be a missed opportunity, to say the least. The point is indeed that we take the energy transition, solar and wind, and we accelerate that to the extent that this is that we actually have a twin agenda of climate action and energy security, both mutually reinforcing each other. So that's the context. Now, there's a couple of bottlenecks, so reasons why this may not materialize the way we would like to see it materialized for many good reasons. And there's many bottlenecks, but I think the one that is most important for this conversation is the bottleneck that just relates to space, land use, available areas, avoiding conflicts with other uses, nature in particular. That bottleneck, if we don't address it, can kill the entire agenda. Yeah. So it's really that level. That's why I'm happy to make time to talk to you. And I think that's the context that I want to say before actually going into the slides. So what has the European Commission done? They've proposed a plan, the Repower EU plan, and they've recognized that this spatial impact of the scale of solar and wind is indeed an important thing to handle. So it has suggested a new approach around zoning, renewables zoning, creating the concept of go-to areas. So go-to areas are places where the impacts on biodiversity, water, other land uses are as small as possible and are still in good conditions for solar or wind. I'm sure I'm saying a lot that my friend Ivan here will say as well. So what is it concretely? So there's an obligation that the European Commission has proposed on member states to identify go-to areas to achieve the 2030 targets on renewables within 1 year after the entry into force. It's more or less around 2025, 2024, 2025, and then to adopt very concrete plans the year thereafter. So, when this 1 year and this 2 years will start depends on the entry into force of legislation. So, but that's basically we're talking the years 24 to 26. Yeah. So that is a time frame that I think is important for all of you working on Earth observation. Is important to remember because that's the moment that people will need you, because we will need a lot of data on areas and where to ideally put them. So go-to areas are defined as priority focus of like artificial and built environments, like solar on the rooftops, for example, is a good example what you can do, but no Natura 2000 or nature-sensitive areas and all of that. Yeah. So basically, just to put a concrete example of a go-to area. So this is not a study from the solar industry. This is actually a study from an NGO called the Nature Conservancy. I don't know if that's for TNC, if anybody's familiar with that. And it's a pilot. And it's a pilot for a part of Croatia. This is the area of Zadar, if people know that. But it's a really interesting exercise because they've layered all types of data onto that area and come to places where the sensitivity for solar is lowest. So everything you see in yellow and light, let's say orange, is optimal solar space without impacting on biodiversity and all of that. It's just, what I'm showing you is just an example. So there's much more detail, but just to give you the idea of that, that's what we need en masse, as I say in French, so on a massive scale. And the demand for that will be huge in the coming years. So let me leave it to this. Happy to discuss further. Thank you. Yeah.
So thank you very much, Dries. I will just have a look if we have some questions online from the Slido platform. Otherwise, I think I wanted to maybe ask you something directly. So, I mean, you basically said that there is quite of ambitious plans from the European Union in order to switch to this green transition as soon as possible, and you explained a little bit also the framework in which member states will need to do so. So my question would be mostly on the barriers, like what do you think as a representative of the solar community, let's say, that could be, let's say, actual obstacles in the uptake of this kind of data from your community of reference, if any?
Yeah, there's plenty of obstacles, none of which are unovercomable. So in that sense, certainly the solar industry is actually really optimistic. That's a lot of this can deliver. What we're talking about, the scale is like, so far we've been installing more or less like 20 gigawatts per year on average. It was a little bit more last year, a little bit less the years before. But basically what we need to do from now onwards is like close to 50 gigawatts per year, every year. So it's ×3 on average, consistently between now and 2030. So it's a real step up. Yeah. So there's questions around what they call supply chains, just like do we have enough global manufacturing of solar panels just to kind of supply? That's of course, that's a reason, that's something that we pay attention to, but we are quite optimistic that the market will react to the demand and that we will see more supply. But there's many other obstacles as well, from the point of view of connecting these things to the grids. It's not only, grids can be quite easily, let's say, full and therefore not really capable of connecting to that. Gets really technical if you want to know what solutions around it are. But I think, coming back to the reason for this meeting, I think really one of the main things that we need to look at is finding suitable place to put all of this. Rooftop solar is a fantastic opportunity to avoid conflicts, but it won't be enough. So it is hard to give the message that we can put all solar on rooftops and we will not have any kind of issues. That's just not the case. So we will also need blue fields, as they call it, solar. And there you have issues of impact on nature, but also public perception, public acceptance and all of that. So I think we need to move into a conversation where it's much more about planning and psychology rather than just kind of targets and ambition.
Thank you very much. And again, I will have a look at a question from the audience also here. Apparently there's none for you. So thank you very much for this insightful presentation. And I believe that you will hear something a little bit more on the opportunities offered by Earth observation in a couple of minutes from one of our pilots here. So I will now move to our second speakers that will provide us and the community with a little bit of the perspective of the wind energy sector. So Mr. Ivan Pineda is with us, Director of Innovation of Wind Europe. And please, Ivan, the floor is yours.
Thank you and good afternoon, everyone. And thank you again for inviting me. I think Dries gave an excellent introduction on where do we see opportunities for collaboration with this community. There are three fundamental questions for wind energy, and I suppose from what Dries presented from solar PV. So to the extent that you can solve these existential questions for us, is to the extent that we will be able to cooperate very meaningfully. The first question is what Dries said, space. So where are we going to put all these renewables that we need? And I think that the tools that you can offer to the community, not only to industry, but also governments, will be fundamental in the acceleration of finding that space. Not because renewables require a lot of space, but because exactly what Dries mentioned is the coexistence aspect of space. I think everybody around this room probably uses a car, but nobody wants to live nearby a petrol station. And that's probably the same with a lot of renewables. The second fundamental question is where we are going to manufacture the technologies that are going to give us renewables. And this comes to where are the resources available. So the interactions that we can have with yourselves to find those places where resources are abundant for manufacturing our technologies will be fundamental. I read the other day in a scientific magazine that actually you can get any material from seawater. Lithium, copper, magnesium. Where are those technologies and how can we leverage those minerals? Because the least that we want to do is being dependent on certain fossil fuels or certain countries to be dependent on materials or certain materials to other set of countries. And that's what could happen with renewables. The third fundamental question is who is going to buy all the electricity that we are going to produce? So any tools that you can have available for the optimization of energy, flexibility in the system, industrial demand, anything that can help also to ensure that the electricity flows go to where they need to be, is going to be fundamental for surviving. So they're very simple, three questions. And I think to the extent that we can agree on those three fundamental questions, the barriers that you presented at the beginning, the lack of knowledge between the two communities, can be easily overcome. And a very important target audience you should have in mind is not only industry, but it's actually governments. Permitting is the single biggest bottleneck that we have in accelerating the energy transition, because it takes 10 to 12 years to have an offshore wind farm that we don't even see. But that's exactly the amount of time that we need to do to triple the amount of all the offshore wind that we have installed in the last 15 years. So the challenge is quite big. One of the most important developers of renewable energy in Europe has to budget 40,000 euros for printouts every single project that wants to be installed. So digitalization in permitting authorities, digitalization activities that you could also facilitate by the sharing of data is extremely important for accelerating this. I think I'll leave it there as an initial statement, and I'm happy to answer any questions.
Thank you very much, Steven, for providing a little bit of food for thoughts, and maybe just to have indeed a little bit more elements for the community here of Earth observation. I was thinking about if you could maybe tell us a little bit more specifically about which would be the needs of the companies of the industry that you represent here today, and because indeed, I mean, we understand that data is key at the moment for, I mean, at least for what both of you said until now, and especially land coverage. It's a very land coverage and land use. It's key information that I mean, it is needed and it will be needed in the future, but maybe, I mean, more specifically for what concerns the actual wind industry, like the need of the sector.
I can tell you a very specific example. Well, actually two, now that it comes to my mind. We have very little knowledge about the interactions between the atmospheric phenomena. We're talking about wind and cloud and pressure with, for example, the phenomena at sea, for offshore wind in particular. So interactions of sea, waves, currents, together with atmospheric phenomena is something that we have not studied enough. I was in a scientific conference recently whereby this was the biggest challenge for the community there, how to understand exactly the right layout of wind farms that will not make, in the very long term, we're talking about 30 to 40 years time, a significant change in the patterns of weather at sea. There are other important data that probably you may be able to actually extract faster in a much concise way with Earth observation, which is migratory patterns of biodiversity. We're talking about birds and bats and sea mammals, all of which at land and at sea share the same space where we are going to install these renewables. And the cumulative effects of those migratory routes, for example, is something that we need to go back decades in time and probably forecast decades in advance to understand if an asset that we are going to build, an offshore wind farm or an onshore wind farm that will last 35 years, is going to alter that pattern of migration. So challenges are out there enough. We just need to go and hunt them. The other example that I believe is going to be very important is share data amongst the Earth observation community. I mentioned authorities, governments, but with the geopolitical tensions that we have today is also with the army, with the MODs, the ministries of defense. Until very recently, half of the territory of France was blocked to any wind farm development because what is called the low flying zones. So areas where the army needs to train at low altitudes. And a lot of that territory was blocked. And for the same reason, there are many other areas around Europe that are also blocked for any type of development. I'm talking about wind, we're talking about solar, or any type of development. How can we ensure that with hard data, we are able to ensure that there is a wind farm or there is a solar PV farm coexisting with many of these economic or security activities? And the superposing of data will help us to do that.
Actually, I think that with what you just said, you, reaffirmed and recalled a topic which was, discussed here, like in the last couple of days, which is the integration of different data and the, interoperability of different data layers, which are key. Also for the users' communities. So thank you very much again, Ivan, and I think we will come back later also to this topic, and I'm very happy you mentioned the example of the offshore wind farms, because yet again we can address it in a few minutes with one of our pilots. And I will move forward to the next speaker, who is Dorian Grohl from European and International Affairs at the CNES, French Space Agency, and that is here with us today to talk and to illustrate the Space Climate Observatory, and is basically also doing a PhD on the use of satellite data for climate change and climate governance. So, Dorian, the floor is yours.
Thank you very much for the invitation and to give me the opportunity to represent the SCO today. I will not be able to give you a full overview of the water sector and what are the needs of Earth observation in the water sector, but what I wanted to do rather was to center my presentation on a single project, which I think could give some insights on how we manage in the Space for Climate Observatory to bridge the gap between non-Earth observation community and Earth observation scientists. So just to give you a brief overview of where I'm coming from, I work at the French Space Agency in the Space Climate Observatory. It is an initiative which was launched in 2019 following what was seen, as shortcomings in the Earth observation sector, and the SCO was thought of as a solution, as an answer to the shortcomings. Namely, the fact that, well, we have wealth of data, but sometimes, more often than not, they are not used for actual policies. And so we can better understand the climate, but it does not really affect how things are being done the same way as IPCC reports are not really effective. We have many applications emerging all around the globe concerning Earth observation, but it's sometimes hard to have some visibility on those applications to make sure that they work correctly and to avoid duplication. And finally, we also noticed that whereas coordination at the international level for space agencies is really well established now through the CEOs, through the GEO, and we have a way of coordinating for those pilots and for this science-based research, it's a bit difficult to have some coordination on the level of applications and of involvement of the private sector. So the Space for Climate Observatory was created in 2019 to kind of answer those shortcomings. And the idea is that it's a network of space agencies, public entities, private entities. It was at the beginning only 24 space agencies. It has widened its scope now, and it's 35 space agencies. And from September onward, it would be open to private and public entities. So we think that many more entities will be joining us rather than only space agencies. And the idea is to support the emergence of operational climate applications, so for climate adaptation, for climate mitigation, and for climate monitoring. And those projects must satisfy a certain set of criteria, namely being operational, using the best data available, using existing infrastructure, and being co-designed with end users to answer some specific needs. So the idea is not to create something out of the blue and arrive and submit it to the users, but to create the solution with them. To give you a brief idea of how the water sector is represented within SCO, there are currently around 60 projects supported by the Space for Climate Observatory. And among the 60 projects, 12 of them are related to the water sector. So obviously, talking about the water sector is at the crossroads of many, many different stakes. You have both questions of vulnerability and disaster through floods. You have questions of water as a resource, and a crucial one, which is becoming more and more threatened. So we have projects dealing with drought and water resource monitoring. And you have also questions of water through biodiversity, because those are, well, places where we have specific biodiversity, which we need to be able to track and monitor for conservation purposes. But among all of these projects, today I wanted to talk to you about the Flood project. So this project was created in 2020. The idea is to have an observatory for flood resiliency in a region of France, which is called Occitanie, in the south of France. And globally, the objectives of the project are to enhance our knowledge of those kind of hydrometeorological phenomenon in Occitanie, to have a better understanding of the impacts of such phenomenon in the local area, in urban and rural areas, to better understand those elements, but also to provide ready-to-use operational data for the local authorities so that they can correctly react and anticipate those flooding. But rather than delving into the technical side of things for this project and explaining to you what has been done technically, I wanted to rather tell you and with insights how the project came to be, how the different communities were involved within this project, so as to give you a sense of how this project in particular managed to have a lot of different actors from other communities than the Earth observation communities working together quite successfully. The starting point of the Flood project was October 2018. So we go back a few years in the past, and in October 2018, there were dramatic floods in the Aude department. So France is divided into regions. Occitanie is one of them, and those regions are divided into departments, and the department of Aude was dramatically affected by those floods. Naturally, a crisis center was set up, and by decision of the central government, some Copernicus data was provided to this crisis center so as to give them tools to, well, monitor the damage done on the territory. This gave some ideas at the level of the department of Aude, because, well, they suddenly became aware that all of this data was not readily available for them and that they lacked some information. So thanks to one specific guy in the Aude department, the responsible for geomatics, a contact was established with the French space agency, CNES, and from there on, a cooperation was set up to work first on a recovery observatory, but then on something which was extended to become a scope project. So here on this slide, you can see a few of the milestones throughout the duration of the project since its creation in 2020, so 2 years after the floods, and until this month, where the projects will be officially open to the public, so at the end of the month of June. This is not to give you a full overview of all the meetings and the workshops that have been organized to set up the project, but rather to give you a sense of how many studies, how many questionnaires, how many one-to-one interviews were necessary to set up this project. Because behind all of these dates and workshops, it's not only a matter of gathering people in the room, having them sat down, presenting something during 1 hour, and then hoping that someone at the back of the room will have one question and work from there. It's really a matter of, from the side of CNES, the French Space Agency, understanding what was necessary for those users for the tool to be useful. And just to give you one specific example of the kind of information that was asked in the questionnaires or in the meetings, for instance, the Chamber of Agriculture was involved, so the local agencies for farming, and to really set up the project and the technical analysis of Earth observation data and to suit it to the territory, there was some questions on the impact of some landscape elements for the effects of flood, depending on the intensity of the rainfall. So for instance, there were some questions to farmers about how do you think that while having hedges changes the effects of drought, of flood, how having some lands covered with grass changes the effect compared to lands without grass. So all of these things, which may seem a bit futile, were indeed all taken into account to kind of synthesize how what are the factors which are interesting to monitor, to follow through Earth observation, and not to spend a few months working on things which at the end have little or no impact on the way the local territory reacts to the clouds. So throughout all of this process and all of these meetings, a whole community was gathered around the float project. At the beginning, as I said, it was only the French Space Agency and the local land and coast agency which were involved at the level of the department behind the project. But then, as the project grew, some new members became part of the consortium. So we had the Copernicus Climate Services, which chose this project as a pilot for this C3S and to found the project. We had then other local agencies, authorities, cities becoming part of the project. We had research centers, so the French meteorological entity or the University of Toulouse. And we also one company joining the consortium. So it's only because throughout 1 to 2 years, some meetings, some workshops, some involvement at an equal level between Earth observation community and non-Earth observation community was organized that the project and the team behind it was able to gather that many people behind. And on the other side, you have the users now. And today there are 35 entities using the FORO. So the goal of the Float project was to create this observatory, this digital platform. There are 35 users. There is a whole community organized around them with newsletter, a community manager, a lot of exchange by mail, but above all, support provided through workshops and meetings. And this, in turn, created some kind of involvement really into the EO communities from users which were really far away from it at the beginning. And now, for instance, the Eau department has submitted its own idea for creating a project on Earth observation to deal with wildfires. So, you know, at the beginning, they were really not aware of what was being possible, what was being done in the Earth observation sector, but through constant work with them, now they are submitting their own projects to the SCO, which is really encouraging to involve non-Earth observation communities. So to sum it up, I do not pretend to have a 5-step working solution to be applicable to all projects for it to be successful. But through this case study and by comparison with other existing projects, I think that there are really 5 points which were important in the elaboration of the Float project and to explain why it worked. The first one was to have a real need at the level of the territory. So in our case, well, the floodings were dramatic and we needed solutions to prevent them or at least to anticipate them. Then there is a need, as it has been said countless times today, of awareness of these solutions. And this was possible thanks to the connection with the French Space Agency. Then there is something which is completely in the order of contingency. That means that it's difficult to act on it. But one reason which explains why the project was successful is that we had on both sides, both in the French Space Agency and in the Eau department, people who were willing to work together in quite an open-minded environment, and not only scientists coming with solutions and thinking they had it all figured out through space. So that was important in building the project. Then there was this iterative methodology throughout the whole 2 years of existence of the project. And of course, the possibility of now having this tool which is working, which can be perhaps expanded to other territories. And well, even if it's not a miracle recipe, I think that it gives some insights on how the non-Earth observation community has been involved throughout this project. Thank you very much.
Thank you very much, Donner, for this very insightful presentation on, especially on the process itself that you put in place in order to engage with the users' communities, because I think I was taking some notes, and for sure part of our work from here until let's say the years to come is most definitely this translation that needs to be done from the needs of the different users community to be reported to the EU, let's say service providers, let's say community that not necessarily, have the same understanding of this the insights of the different sectors. So this was indeed something that I believe it's key for everybody. And well, just indeed, I was wondering if part of this process was also to enlarge the basin of the users, because you mentioned that you started with a couple of cities in this very specific region, and then it was enlarged to get to 35 different authorities. And as I mentioned yesterday, one of the outcomes of the ERSC survey, it's really showcasing that the big share of the market for this kind of solution is still institutional market. So it's still let's say composed by public authorities. So this is a very interesting result, I believe, for everybody. And I just wonder if you can tell us a little bit more about this.
Well, to be sure, the users are very much institutional for the time being. That's also the neat thing about involving the non-Earth observation communities, that we didn't have, well, the team behind the project for sure publicized what was being done, but there was also this effect that, well, users spread the word, and some other cities, some other local authorities became interested and expressed their interest to join without necessarily doing a lot of advertising on the project. So because they were involved and happy with how things were being developed, they then spread the word, which was important, I think, in explaining why there are no 35 users for the platform.
Thank you very much. This is reassuring that part of the opportunity I mentioned in my slide were correct. So thank you very much. And I think it is now time, also for the benefit of the representative of the users communities to showcase a little bit of what eShape is currently doing and can offer to the different communities. So I will start by introducing the first speaker of today. So Ilias Fontolakis, I hope I pronounce it well. And Ilias works as a researcher associate at the Institute of Astronomy, Astrophysics, Space and Application and Remote Sensing at the National Observatory of Athens in Greece. And he will tell us a little bit more about NextSense, which is basically an application on solar energy. And Ilias, the floor is yours.
Okay, hello. Thank you for inviting me here. I will talk to you about the NextSense system for solar energy nowcasting and forecasting, and I will begin directly with the slides. Let's see. Okay. So renewable energies will play a key role for the success of the initiatives for the success of global and international initiatives relative to the mitigation of climate crisis. And solar energy has some advantages relative to other renewables. Actually, it's cheaper and it creates more job positions. So, increase of renewable energy use in the last years, and this increase is expected to be larger in the future, has already led to the need for fast, accurate, and high spatial and high temporal resolution of solar energy forecasts. So, in order to nowcast or forecast solar energy in different time scales, we need to know and understand changes in the atmosphere and how they affect solar radiation. Earth observation resources gives us the opportunity to, if we utilize them, to provide innovative and mature products and services for renewable energy development and management. Our objective with eShape is to exploit all available data sets and sorry, I have to backwards and provide short-term and provide nowcasting and short-term forecasting of broadband and spectral surface solar energy at high resolution in order to support TSOs, DSOs, national solar planners, etc. The expected user community is grid operators, ministries, energy trading companies, etc. We have used the GeoCradle infrastructure in support of this project, as well as the Beyond infrastructure. In the beginning of the eShape project, the system was simpler than it is now. It was the Sense system. Actually, we used Earth observation data, Copernicus data, and climatological variables as inputs to a radiative transfer scheme, including radiative transfer simulations and neural networks, and we were producing nowcasts of solar energy on a very high spatial resolution. In the context of eShape, we managed, okay, give me a second. The video is not playing, but it's not a big problem. We managed to improve our ability to simulate solar energy and to achieve having 1.5 million points covering the whole Europe as well as Middle East and North Africa. We achieved to have this, the solar energy at this point, simulated in less than 3 minutes. Then we further upscaled the system by adding the cloud motion vector module. So actually, we used some statistical techniques and managed to have a forecast with an horizon of 3 hours ahead. And lately, we try to develop a long-term forecast. For this purpose, we incorporated cloud optical properties that we are getting from numerical weather models. The horizon of this forecast is 3 days. I will talk to you now about some existing collaborations. So we are collaborating with the Ministry of Electricity and Renewable Energy of Egypt. They actually use our services for solar park characterization, planning, and economical studies. And we also collaborate with the Makti Yaqub Heart Foundation Center in Egypt. They use our services in order to electrify a hospital using PV panels and also send energy to the surrounding area. The Public Power Corporation of Greece also uses the nowcasting service and they were also interested for aerosol effects. So we recently performed a study, and we quantified the effects of aerosols around the whole Mediterranean basin in the context of this collaboration. The independent power transmission operator of Greece, they also use long-term forecasts of solar radiation for 3 particular positions where large PV parks have been are now placed. The independent power transmission operator of India, so we were trying to expand our domain and find users in India. It's not so simple because we have to use different Earth observation data sets. So in the context of this collaboration, we have created a climatology of solar energy in Egypt that will be used by local operators in order to plan the optimal positions about their investments and where to place the PV panels. There is another ongoing project, and we are collaborating with the Eratosthenes Center of Excellence in Cyprus. In the context of this project, we are going to adjust our services to the needs of the island of Cyprus and actually to the needs of the region of Middle East and North Africa, and provide services that are more dedicated to these areas. And since we actually produce spectra with our system and not integrated quantities regarding solar energy, we can also give some more quantities related to health and agriculture. For example, the UV index is a metric of of the ability of ultraviolet radiance to induce erythema on human skin. We produce now casts of this quantity, and this is a service that is being used from a cruise company in Greece, which informs its clients in order to protect themselves. And you also see here a map of the photosynthetically active radiation that has been created in the context of a study. And in order to close this presentation, I will summarize and say that we are trying to use all the opportunities that are given to us from eShape, interact with users through the dissemination activities and everything that we have, and co-design services that are tailored to their needs and exploit in the best possible way the Earth observation data sets and whatever is provided to us by EUMETSAT, EMSA, WF, and Copernicus. So that's it. This is our team, and thank you very much.
Thank you very much, Elias, for the presentation. And I don't know if there is any question also from our panelists, or because actually I do have one question for you, which is mostly about the access to data, and if there is any challenge and benefit that you experienced in the use of energy data record for the development of those services that you've been showing to us.
Yes, actually the amount of data is very large. That's the main problem. So we have to find a way to work with this data. And okay, this is not so simple because it actually needs people to do it. So it creates other kind of issues, like issues of funding, of finding resources, computational resources, etc. So this is the main issue that I think that we faced.
Also, there is a question for you.
Yes, thank you very much. Could you tell us a little bit more about which countries or geographies you currently cover with this tool? Yeah, thank you.
Yes. Currently, we can provide nowcast and short-term forecasting for Europe and for part of North Africa, and well, this is it mainly. So now we are trying to expand our service. So we are limited in the Mediterranean basin and Europe below actually 60 degrees of latitude, but with a very good, with a 5 by 5 kilometer resolution, which is okay.
Thank you very much. And I do not see any question in Slido from our audience. So I think that we can move to the next presenter who should be connected with us online. And I will introduce Merete Badger, senior researcher at the Technical University of Denmark, and her research is basically on the application of remote sensing technique in the wind energy, wind resource mapping, and studies of wind farms' wake effects, and way more that she will explain to us in a second. So she will also providing us and illustrating a little bit the pilot project on merging offshore wind products. So Merit, the floor is yours. I hope you can hear us well.
Yes, indeed. And I hope my slides are visible.
Yes.
Okay. So I represent a pilot in the renewable energy showcase, and it's by the Technical University of Denmark. I think the motivation for our work has been well described and highlighted already by other panelists. It's the ambitious targets of being carbon neutral. It's ambitious goals for installations of new offshore wind farms, and that includes, of course, floating offshore wind energy. Currently, we have around 25 gigawatts of installed wind power offshore, and the expectation by 2030 is 111 gigawatts. So it's really a massive upscaling of the current capacity that we are looking into. And as mentioned also before, one of the barriers is to find enough space at sea for all these new installations. So how can EO help us with that? If we look at the current tools or data sources available to us, we have meteorological masts. We can mount LiDARs, laser instruments offshore. These technologies are quite expensive and also difficult to maintain in the harsh environment at sea. And when we get to water depths deeper than 60 meters or so, it's also challenging to install foundations for the towers. Then we can use numerical weather prediction models, so to speak. Reanalysis data are readily available, but the spatial resolution is fairly low. And to get dedicated simulations for a given site, one would have to order and pay for the data. They're not readily available for download. EO-winds, in contrast, are available. Some of them are provided at high spatial resolution. We illustrate that in our pilot. Others are available at lower spatial resolution, but with a higher revisiting time or temporal resolution. But in general, the temporal resolution we can achieve from satellites is not as good as what in situ measurements or models can provide. We also have the challenge that wind retrievals from satellites are performed for the level 10 meters above the sea surface. So we need to find ways to and synergies with other types of data to extrapolate these winds to higher levels where the turbines are operating. In our pilot, we work with two types of wind products. one is based on synthetic aperture radar. It's a type of microwave sensor. The other is ASCAT, which is a similar type of sensor, but operating at coarser resolution. And ASCAT products are readily available for download, so one can simply get the wind speed and direction several times a day. Whereas for the SAR, we have to do the wind retrieval ourselves, but the benefit is a much higher spatial resolution. It's on the order of 500 meters. And as the map here to the left illustrates, we can really resolve the different wind farms and also the wind climate for the areas surrounding them with SAR sensing, whereas ASCAT is more for mapping, monitoring of larger areas at a coarser resolution. And the coastal areas are not well covered by ASCAT because we get mixed land and sea pixels that we have to mask out. Just a few examples of what we can do with the images the wind speeds we retrieve. Here in the upper left corner, you see a SAR backscatter image over a wind farm in the UK. The wind is coming from the southwest, and you can probably see that there's a dark area downstream of the turbines. When we convert to a wind field to the right of this map, you can see that this dark area remains as an area with lower wind speed. This is because of the wind farm wake effect, the fact that the turbines are extracting energy from the wind and creating this area with reduced wind speed downstream of the turbines. We've had the opportunity to compare with ground-based Doppler radar here at this site, and we see a lot of similarities. The radar observations are in the lower right corner, and you can see a lot of similarities. We cannot quite resolve the wakes of the individual turbines with SAR and EO, but we can see that the wake effects are visible in both types of maps. Another thing we can do is use the EO-based wind fields to check or validate model simulations. Here's one example from the island of Crete in Greece with northerly winds. To the left is a model output based on the weather model WRF, and you can see that the island and its topography generates a lot of variability in the wind field. Some areas behind the mountains are low wind speed, and other areas we have an accelerated wind speed where the wind flow is forced through mountain gaps. And we see similar features in the SAR-based map to the right, but you can also see a lot more detail in this map. So overall, there's good agreement between the two, but the SAR can resolve a lot more detail about the wind patterns in this area. We retrieve these SAR wind fields on a daily basis and provide them in near real time through our service. And the service is a website that is shown here. So our goal is to make the wind fields available within the same day as they're acquired by the European mission Sentinel-1. So users can go in here, they can browse the colorful maps, but they can also register and download the data behind the maps. We have collected this type of data for many years, more than 20 years by now. And when we have such large data sets, we can start to combine them into wind resource maps. Here we have an example based on ASCAT, scatterometer to the left, SAR in the middle, and model simulations to the right. And I think you can probably see that the map in the middle based on SAR is showing more detail than the two other maps, but altogether there's good agreement between the three. Here we have used WRF model simulations to extrapolate to the 100-meter level, which is more equivalent to the height where wind turbines operate. These wind atlases, as we call them, are also available through our service. At the moment only for display, but we're planning to also make the data behind available for download. So in eShape, we have put a lot of emphasis on the co-design and the dialogue with end users. We have been in contact with 3 different types of end users from 3 different companies in the wind energy sector. And I think one major gain from being in eShape has been, or we have received a lot of support when it comes to dealing with the users, and also especially with structuring all the different inputs they came with, because you're often in a situation when you interview users that one will say something and another will say the opposite, and you end up with a lot of information, and there's a need to structure it. And eShape provided some really helpful tools for doing that. So one of the outcomes of that was that we improved our documentation, because the users, all 3 users actually said that they found the learning curve quite steep when it comes to working with EO data, and none of them had really tried it for real because they felt it was difficult. So we developed some documentation pages with video demos and screenshots and descriptions and links to literature to guide the users on how to use the website, and also how to use the data behind the website, the data they can download. Another outcome of the user interviews was that we have expanded our area of coverage. Initially, we covered the European seas, and I have to say that sounds perhaps simple, but it's actually massive data processing that's required to retrieve the wind fields daily from SAR over the European seas. We have now added most of the seas in Southeast Asia, and also the seas of the US East Coast and the Great Lakes. And these areas are chosen based on the user interests. There's a lot of wind power development going on in those areas. So of course we need to support that and provide the data for these areas. So in summary, it's very important to remember that EO winds are available for more than 20 years. So we don't have to wait for the time it takes to install equipment and measure winds. It's all at our fingertips if we know where to find it. The EO data can sometimes provide higher spatial resolution compared to the mesoscale models, which are what's widely used in the industry at the moment when it comes to the planning of offshore wind energy. And another major advantage of the EO data is the large spatial coverage. Basically, we can cover any location on Earth. So it's just about balancing the demands on computational efforts with the need for the data. The temporal sampling is not as good as for other data sources, as I mentioned. So I think nobody believes that EO will be the solution to everything. It should be seen as supplementary to other data sets and solutions that are already available to the community. We have to constantly develop new ways to use EO data in synergy with other data sets, for example, to extrapolate the 10-meter satellite winds to higher levels. But basically, the EO-based wind maps we can deliver can serve as a basis for the installation of in situ measurement stations where more accurate measurements can be obtained. Also for checking the numerical simulations that are widely used. They can be used for wake analysis, as I demonstrated, and eventually, hopefully, also for decision making. That was my presentation, and I can just add that I agree with everything that's been said so far about the awareness and the learning curve for using EO data. That's very much also true for our pilot.
Thank you very much, Merete. I think that with your presentation, you managed actually to address quite punctually some of the points that were raised before by Ivan. So I think I will firstly ask him actually if he has any question for you. And
just a quick one. Thank you again for the presentation. You mentioned that the pilot, the eShape project, helped you to connect with industry. Where do you think that your solution, your project, can also benefit other parts of industry apart from the ones that you have discussed with?
I think one thing we discovered is that we have to get in contact with different parts of the companies. So usually we would contact many companies have a university contact. That would be our first point to go to. But often I think what we really need is to get closer to the financing decision, talk to the people who are working with that, and that's something we haven't been so good at yet, to talk to those who actually need to make decisions about wind farm projects.
So thank you. I think that Ivan here is satisfied by your answer, and I think I will move to the next speaker, who is also connected with us online, and it's Simeon Wilkinson, data analyst and system engineer at the Plymouth Marine Laboratory. He will present today, one of the eShape success stories about a commercial service that is, about water visibility, and that is already supporting one of the users in indeed their market needs. And of course, Simon will tell us a little bit more. The pilot is called DIVE, for Water Visibility Information for Dive Planning. And I will leave the floor to Simeon to tell you a little bit more about this project. Simon, I think you are on mute. We cannot hear you. No, unfortunately, we can not hear you. I think that maybe the issue is with your sound system. I don't know if you want to try to maybe unplug your earphones. Yeah. Yes, now we can hear you.
Can you hear me now? Yeah, cool.
Yes.
Right. I think that should be up now. Okay, so my name is Simeon Wilkinson. I'm from Plymouth Marine Laboratory, and I've been working on this project with myself, Peter Walker, and Darren Snee, which is called DIVE, Simple Water Visibility Information for Dive Planning. Go to the next slide, please. And I realize the information is kind of duplicated there, but so I can go to the next slide, that's fine. Okay, so PML is an independent provider of policy relevant scientific research for the interactions between marine environment and society. And we're recognized for delivering pioneer world-class science for over 4 decades. And we produced more than 800 peer-reviewed publications over the last 5 years. 20 papers from 2018 are already in the top 5% of all research outputs scored by our metric. This is a tool that captures alternative metrics such as digital and social media. And the Centre for the Centre for Geospatial Applications, or CGA, which we're part of, is responsible for delivering GIS tools and web applications that are currently used by around 15 EU and global projects. Next slide, please. So a little fact there from Medium is that there are approximately 3.2 million active divers in Europe at the moment. That's probably decreased during the time of COVID, I imagine. So visibility in the water is a safety factor in both recreational and commercial diving, as well as a large factor in the enjoyment of recreational diving itself. Visibility can be affected by many factors or variables, some of which we can actually measure from space using EA data. Next slide, please. So EU science programs such as Copernicus are producing a large volume of data which relates to the quality of seawater. These data types are invaluable resource for scientists, but they're not always easy to understand if you're a non-scientific user, maybe a member of the public or a member of a dive community. So Dive Solution, what we do is we'll process data sets provided by EU Copernicus program, and we're using the CMEMS dataset. And our intention is to present this to the end user with a simple to understand visibility score for a selected dive site. And then with that in mind, the recreational divers can use this information when they're planning their dives. So if the water visibility is really terrible, they can look at this beforehand, and then they will know it's not worth actually going to travel to the dive site, and save them time and probably money as well. And next slide, please. So a quick overview of how our dive system works. So every day, an instance of the dive system is instantiated in the cloud, and we're using the EuroGEO platform. And Dive accesses the latest EO data from CMEMS, which is available on the EuroGEO platform, so we don't need to upload the data. And that will build the visibility scores for all the sites we currently have in the database. And then once that happens, the latest scores are uploaded to the Dive database server, which is currently, if you go back a slide, please. Sorry, thanks. The latest scores are start again. The latest scores are uploaded to the Dive database server, which is hosted at PML currently, although we might intend to possibly put that cloud in future. A member of the diver community will query the latest visibility scores for their chosen dive site, and they can do this through our mobile app, which we've built. Next slide, please. So the current state of the app is it's available, although it is currently in a beta phase. So as you can see from the screenshots down there, it's not the prettiest one in the world, but it does work. So we get access to diving locations via a searchable list. We've got an interactive map for browsing different dive site locations. It's kind of a slippy map, a bit like Google Maps. And then this produces a easy to read score system. So to estimate visibility conditions for each dive site. Next slide, please. It runs 2022. So this year we're hoping to, because at the moment we've just got the simple score, we're hoping to add the following: wind data, wave data, temperature data, and historic conditions, just to add a bit more information rather than just a score, because then I think that would help. Even if the water visibility is good, divers might take a few other things into consideration, like if the sea's rather choppy, or whether the weather's just terrible and they don't want to go out, basically. And they can also see previous days how it's been as well. So in summary, Dive provides the current or recent visibility conditions for selected diving sites. So we're providing an intuitive app that doesn't require technical understanding when interpreting the data, whereas in its raw format, particularly probably mostly scientific people would understand, but again, members of the dive community might not, so it would help them. Gives us an interactive map for browsing diving locations, and this helps to plan successful diving trips. And we believe that this score quality will improve with user feedback and usage of the app. And the app is available in the Play Store currently, and there's a link on our website below. Yeah, thanks very much.
Thank you, Simon, for this quite user-friendly and comprehensive presentation about the service that you've been developing. I'm afraid that for time management reasons, we cannot, open the floor for question this time. And I will actually leave now the floor to my fellow co-host, Dara from Evenflow, who will manage the panel discussion.
So, hello everybody. Welcome to the final discussion of the day and of both days. My name is Dara Boyle. I'm a consultant with Evenflow, and I'll be moderating this panel discussion. We're going to talk a little bit about sustainability. So we're going to address some of the user communities, the needs and wants of the industry, and then how the E-Shape pilots can address that. First up, I believe we have Bruce McCormick online. Is Bruce available?
Yes, I'm here. Can you hear me?
There he is. Hi, Bruce.
All right, can you hear me?
Yes, we can hear you loud and clear.
Okay.
Bruce, can you give us a little comment about your work with the non-EO communities and the pilots within E-Shape, please?
Okay, I believe I've got 5 minutes and I need to be very brief. My understanding was to give a kind of overview perspective of how one engages with non-EO community people. I am, just to mention background, I am the Vice President of EuroGEO, the European umbrella organization for geographic information. We have people, members across the whole of Europe. So given this short period of time and given my understanding of the brief, how do you engage the non-EO community? I would say there's 3 fundamental questions. The first one is, who is the target community or target audience? The second one is, what are the benefits which I, presuming I'm a supplier, which I can provide for them? And the third one is, how should I connect to them to be able to engage with them such that they eventually pick up and use my service? So those are the 3 basic questions. The first one, the target audience. Now, all of us will be absolutely aware that the potential target audiences for EO stuff is ranging from individuals to large corporations, SMEs, government departments, etc., etc. So there's a kaleidoscope of possible audiences out there, and it becomes quite difficult to generalize. However, from my experience, an absolutely key is to understand well the target audience. Now, I've been at lots of meetings where people say, oh, yes, we need this, we need that, we need this. But you've got to get way below that level. You've got to have almost a forensic understanding of who they are, what their capabilities are, what their real needs are. And when I say real needs, I've been in meetings where people say, yes, we need that, but actually they only need the data or the information once a year or maybe once every 3 years for a strategic review. Whereas on other occasions, people need the data every day, almost every hour of every day. And these are completely different situations. So what I've always found is quite useful is to try to get inside the life, the work, the environment, the head of the potential users. Now, one time I took this idea to an extreme. I'd written a bit of poetry, and I tried to see the world from the perspective of a cow. Now, I must say I couldn't actually do it. I was completely unsuccessful, but the principle is try and get inside the community and understand who are the key people, what are their needs, their real needs, etc., etc. What do they want? Now, when you're talking about the non-EO type community, and very often you're talking non-technical people, they are, from my experience, and I'm sure it's yours as well, they are absolutely not interested in the technical stuff, the details, the data, all the kind of stuff that turns us on. They really want to know, they want information, they want knowledge, they want insights, and very importantly, they want to have an ability for predictions. What's coming next? So a good example was we in Ireland, where I'm based, we had an E-Shape workshop last year, which focused on agriculture. And in the beginning, we thought, wow, agriculture now, wow, all these things, these wonderful things that EO can do for agriculture. We focus on the farmers. So we spent quite a lot of time thinking and trying to get farmers involved. But actually, what turned out, the real target audience was not the farmers themselves, but the extension officers, whether they were private sector companies that advised farmers on what to do, when to do it, etc., or government. So the real target was not the one that we thought it was actually extension officers. I'll come to the second point, the benefits. Now, the one thing is people like us can rattle out all the benefits. We're really into that space, but it's the benefits that would benefit the potential target audience. And you come back to the first point, which is really the critical one, know your target audience. Again, in the workshop that we held last year, focusing on the agriculture, there was quite a lot of talk initially about crops, whereas in Ireland, it's grassland, that's the key one. And it turns out that particular kinds of diseases are really what would be useful to be able to track through EO and provide a service linked to those particular diseases. The benefits, lots of them, as I mentioned. My time is really running out, so I'll go to how on earth do you actually connect meaningfully with this target audience, with these user communities. And as we all know, now there's a plethora, there's a whole range of different vehicles and routes. And I mean, I could talk about the different ones, but I just make a quick throwaway line that mobile phones are becoming an increasingly ubiquitous and important way in which to connect to users, beneficiaries, and so on. But one of the thoughts that I've certainly experienced with regard to how do you connect to people, and it's not applicable all the time, of course, but it is one way to give some thought to, is to engage them in the process of shaping what they get. And that might be shaping the nature of the service, the tool, the data, whatever it is, but give them a level of control of that process. So once one does that, one tends to get buy-in and you get commitment. And what you will find is that you get champions begin to emerge, people who will spread the word. So it's no longer people like us in the EO type community. It's people out there in the non-EO community who are the champions and are spreading the word. So my time is now up. I'm just checking. My time is now up, but I hope I've given a few very broad overview kind of ideas that could be picked up for dealing with non-EO people.
Thank you very much, Bruce. As an Irishman myself, it seems my motherland has rubbed off on you and you're writing poetry now, so that's good to hear.
My accent is not Irish, though.
No, I know.
It's South African.
Exactly. I didn't think it was Irish, but okay. So as you mentioned there, know your target audience. We're going to move over to the user community representatives here now. We're going to speak a little bit about some of the trends in their industry and the wants from their industries. And as Remco mentioned earlier on, sometimes it's nice to not talk about space for a while. So Dries, I know there's some time constraints with you, so I'm going to come to you first. How big of a role do you see the solar energy industry playing in the various visions we have coming up, more specifically climate neutrality by 2050?
Yeah, thanks for that question. So I hinted at it before. There's a level to which I sometimes notice that people don't always fully grasp the scale of the energy transition. The energy transition is not just about solar and wind, and as much as possible, it's also about efficiency. It's also about electrification. It's also about making our use of energy, decouple that from economic growth as much as possible. But you can't get around the fact that the amount of solar and wind that we need to build in the next years and decades is just really tremendously huge. So that really, gets us to the conversation that we are now. You also mentioned in your question 2050. That's important, but actually it needs to be quicker than that. The electricity sector needs to be clean, zero carbon, whatever word you want to use, by 2035. And that is according to the timeline of the International Energy Agency's net zero pathway. Of course, we're going to electrify a lot of things. So electricity becomes the biggest share of our economy quite soon. So basically what you get to is a global energy system that is primarily powered by solar and wind. That's the importance of these technologies. If I may also just pick up free riding a little bit on my time here, on the user community, and then the comments from Bruce McCormick, which I really appreciated. That's indeed really important. Understand who your target audience is and what they want and what they need. And I just want to come back to that key points that also Ivan made. So there is a huge need for spatial planning on renewables right now with national governments and regional governments and local governments, even on a city level. So I think that is the key target. Of course, industry can help with that as well, but I come personally from an NGO background. If industry comes with a spatial plan map for discussion, the NGOs will just not trust it. So that you need this kind of neutral convener of a conversation based on a proposition of spatial planning by a government, and that is just really important. So I think that's where you need to look at. Think about funding from the European Commission, from national governments, and they will have to do this by law in a couple of years. Yeah. So either they can anticipate and start now, or wait till then and do it then. So yeah.
So do you think policy is going to be the main driver for forcing people to bring on the likes of solar in the future?
Yeah, so policy, I think, will mandate having a good plan. It won't mandate, let's say, where to put it exactly. But so what the target audience is national governments or regional governments that are able to land a plan that all of the stakeholders in a democratic way have been consulted around, talked about, and agree on. And then we can accelerate the permitting, environmental impact assessment, and boost renewables in the way that we need to. So that's the end goal that we need to reach. And we don't need to wait for legislation or for mandates. You know, we can actually, if you're a government that anticipates a little bit, you would be happy to engage with the EO community right now.
Thank you very much, Dries. So speaking of getting to know your users, Ivan, can you tell us a little bit about what the current technological trends are in wind? And let's speak non-EO trends for now, and then we can bring the EO into the conversation later.
So I think one of the big technological changes that have brought cost reductions in wind energy is going for very large turbines and very large wind farms. So we need to think the tools that enable us to increase sizes in the machines with all the challenges that brings, logistics, manufacturing, and operation. A lot of the tools that we have today, and that actually I hear from from the presenters, if we go back in time, I think the evolution of renewables was at the very beginning. Okay, let's have a solar PV module or a wind turbine that actually delivers electricity. So, let's focus on getting that transformation done first. Then, after many years of been trying, now we got this turbine that actually rotates and yay, it produces electricity. It doesn't fall over when the wind basically blows it. We are now going to optimization of wind farms, optimization of plants. That's where a lot of the applications are. Let's optimize a power plant. Okay. The next level of technology development is how can we optimize the entire energy system? How can we ensure that we integrate all these technologies with the grids, with the demand, with storage, or with other carriers like hydrogen?
Very good. Thank you, Ivan. We were going to come to Jean at the very end, but I know there's a time constraint here, Jean. So this is Jean Dussart from DGRTD. Jean, can you just quickly comment on how the community of EO service providers can help ensure EuroGEO meets its vision?
Yes, thank you. So I'm sorry to rush and to change a bit the order, but unfortunately I have to catch a flight in 1.5 hours, so I'm a bit at the edge. But no, what I want to refer to is you might have heard that there was a competitiveness council a few days ago, and they sketched the member states came to an agreement on their vision for Copernicus by 2035. And one of the important aspects of this document is the necessity to strengthen the uptake of Earth observation by a wide range of community. And for the first time, they mentioned specific ones, including energy, of course, with the Repower EU plan that was adopted, and the particular and the issue, the terrible issue of the invasion of Ukraine by Russia. But what I would like to emphasize is that with all those 37 pilots that have been developed by eShape, you have gold in your hands, because you know what is uptake. You don't need to be told by the top down, by the decision makers, how to make sure that your Earth observation products are effectively endorsed and used by a community of users. So now what probably the community needs is to further engage in increasing the visibility of those services, use those marketplaces. I was looking with interest to a French initiative, the Space Data Marketplace that has been launched by a number of big players in France, including Airbus, Dassault, Thales, and I think there are 10 EO players, but it's something we have EO more, of course, in Ask, and I think that we should build further, because that will be the best way, a bit like Amazon is doing with all this market store, to show up to the community. And by doing so, by increasing this visibility, I think then you would have reached the objective that we had assigned to EuroGEO, to build a framework to develop a vibrant Earth observation community.
Thank you, Jean. You can make your flight now. Dorian, from your point of view, what is the current status of EO in water vulnerability monitoring? How prevalent is it in the sector, and what do the sector players think of it?
Thank you for the question. I will not take too much time, because I think the situation is quite similar to other sectors, in that we know there is a rising awareness that this data is existent and can be used. You have to go back a bit in the past to see how it was done before. You have a lot of sensors in the basins and water. You have a lot of people taking measures by hand to understand what's going on. And with EO, you have to have an honest overview of what is being possible, which means that, well, for sure, you have updated data, you have a wide array of areas being covered. So it's easy, it's affordable to monitor multiple sources at the time. But at the same time, you have some technical difficulties which are still relevant in Earth observation data for water. You have questions of optics, because water surfaces are quite tricky to monitor. You have questions of what kind of indicators can you do using only Earth observation data? So all of these questions are still being figured out. You see a lot of projects being developed by World Bank, by EuroGEO, by eShape, EuroGEO on this kind of issues, but I do not think that for the time being it's widely used throughout the sector, but it's for sure gaining momentum.
It's growing. Thank you very much, Dorian. Given that we're a little bit tight for time, I might move on to the eShape representatives here. Just so you know, for a little bit of context, there's 37 pilots in eShape, and all 37 of them have been working very hard recently to finalize sustainability plans within the project. So we're going to discuss very briefly with some of the pilots their experiences in trying to plan for their sustainability plans. If Maretta is still on the line, I might ask Maretta, when it comes to sustainability planning, what were the main challenges you faced? So a lot of the pilots are very good on the technical side of things, but often maybe they lack some understanding of the economic side of things, the financials. What were the kind of challenges you came up against?
Yeah, I think indeed being a researcher is perhaps the biggest challenge, because we are just not used to working with markets and sustainability plans and so on. But I think also we should perhaps just stop at some point and partner up with the companies who can do the full-scale processing and so on. Maybe we hold on for too long to the operational processing of EO data. So we could be better at partnering up so others can take over once the science is done, and the development, and others can then put it into production. I think that would be probably the best solution in my experience, but we haven't done it ourselves. So I'm sure that solution is also not straightforward.
But I guess in the final year of eShape, the plan is for most of the pilots to make that final bridge with industry, similar to what you were presenting in your own presentation there. I might ask, well, Elias seems a little bit preoccupied here. Is Simon still on the line?
Yeah, still here.
Sorry, Simon, so we actually spoke earlier and you were telling me you're very much on the technical side of things and you're using cloud computing services with your pilot. So how do you plan to sustain your pilot when it comes to increasing prices for computing and storage?
Yeah, so had a think about that. For the moment, the only bit we're doing in using the cloud tech is the raw data that we're pre-processing that gets used within the app. Yeah, so obviously price is going to increase in future. What we've been looking at doing to make that more sustainable in future. So at the moment, the data when it's processed, that's just running on a full virtual machine. But we've been looking at, not just in this area, but other areas as well, looking at containerization. So it'll make it a more portable product, and we don't even need a whole operating system to make everything work. So we could do that with all parts of our application, apart from the mobile app, of course. But in that sense, you would need less resources. So that should save cost and data charges as well when using a cloud provider. And if you want to switch provider that might offer a better deal, then the whole service is portable that way.
Thank you very much, Simon. Elias, I may come to you. How was your experience in sustainability planning in eShape, developing a business plan, developing an economic sustainability plan? Where were the issues for you?
I didn't hear your last question.
Sorry, I said, where are the issues when it comes to within eShape developing your business plan or your economic sustainability plan?
Okay, in particular for myself, I'm coming from the research, and I mean a pure research field. So it was something really, really new for me. I mean, it was not very, very easy to adjust and feel how it is to understand actually the needs of the market regarding your project and your product. Sorry. Well, beyond that, I think that there are some issues that are difficult anyway. I mean, we are, for example, trying to make tailored products for the users. So in order to maintain each of them, you need resources. I mean, it's not like we are doing something and this is it, so you can do your job now. We are doing a lot of different things, and I found it very difficult to think of a way to have solutions for the maintenance of each of them. So I think that this is the most difficult part in our case.
Thank you very much, Elias. Well, I have to congratulate the eShape pilots, all 37, because we've been reviewing all of their sustainability plans, and everything looks great so far. I think that's pretty much the end of the day, certainly the end of this roundtable. So I'd like to thank all of our panelists and all of the people online. And I guess we can close it from here. Oh, sorry, Emmanuel will actually close the day. So thank you very much.